Welcome to the lecture series on Introduction to Partial Derivatives. So this topic comes up in second semester under the course Algebra 2 and Calculus 2. I'm Mary Joyce. So let us get introduced to functions of two or more variables. For each real value of variables x and y, we have a unique real number which is associated with the variable z. Then we say that z is a function of two variables x and y and is denoted by z equal to fxy. So here x and y are called independent variables and z depends upon the value of x and y. So we are dealing with functions of two or more variables. Now, what is partial derivative? If z is a function of two variables, then the derivative of z with respect to x, that is when we treat y as a constant, is called the partial derivative of z with respect to x, and it is denoted by dou z by dou x or fx or dou f by 2x. So z is a function of x and y. So when we are differentiating partially with respect to x, we can either denote by this notation or fx notation or dou f by dou x. Similarly, the derivative of z with respect to y when we treat x as a constant is called the partial derivative of z with respect to y and is denoted by dou z by dou y or fy or dou f by dou y. Understand, here we treat y as a variable and x as a constant. Here we treat x as a variable and y as a constant. The notations for higher order derivatives are fxx, fyy, fxy, fyx. Fxx means we partially differentiate dou f by dou x once more with respect to x. Dou f by dou y means we partially differentiate f once more with respect to y. Dou xy means we partially differentiate f with respect to y again. Let us take an example. If u equal to a function of x and y, and we are asked to show that this expression is true. The first step is when we start writing the solution, we rewrite what is given as u, then we do dou u by dou x, that is we partially differentiate u with respect to x. Understand, when we do this, we keep x as a variable and y as a constant here. Let us differentiate x cubed. Derivative of x cubed is 3x squared minus. When we differentiate this partially with respect to x, understand y is a constant, like just like 3. So 3y square is a constant. We write 3y square and derivative of x is 1. So the derivative of this term is 3y square. Now what is the derivative of x? Derivative of x is 1 because x is a variable here. Look at this term e raised to x cos y. So here cos y is a constant. So derivative of e raised to x cos y is a constant. It is written as it is. Derivative of e raised to x is e raised to x itself. Derivative of 1 is 0. That's why nothing is written here. So what is this expression? This is dou u by dou x. Now let us differentiate this expression once more with respect to x. That is, x is a variable. So derivative of 3x squared is 6x plus. Look at this expression. It's completely constant. So there is no derivative for that. Even when we have 1, it's completely constant. There is no derivative written here. Look at this term, e raised to x cos y. Derivative of this term with respect to x is cos y is a constant. Derivative of e raised to x is e raised to x. Now let us differentiate equation 1 partially with respect to y. So now you have to understand that the variable is y, x is treated as a constant. Let us do that. Derivative of x cube. Derivative of x cube is 0. Nothing is written because x cube is constant when we differentiate with respect to y. Look at this expression, minus 3xy square. So minus 3x is a constant that is already written there. The derivative y square is 2y. That is why you get minus 6x because 3x is already there into 2y gives you 6y. Then let us come to this expression. It is constant, no derivative. Let us come to 1. There is no derivative because 1 is again constant. Look at this expression here. E raised to x is a constant because we are differentiating with respect to y. Derivative cos y is minus sin y. Hence, the derivative with respect to y is this expression. Again, let us differentiate this partially with respect to y. That is, here y is a variable. Minus 6x is a constant. Therefore, we have minus 6x into derivative y is 1. Again, let us have this expression. Derivative of minus e raised to x. E raised to x is a constant. So minus e raised to x is written as a constant. Derivative of sin y is cos y. Hence, we have this expression. Now we are asked to, in the question, it is asked to add them. That is, we have to add this expression and this expression. Let us add them. You can see 6x and 6x cancels. E raised to x cos y minus e raised to x cos y cancels. So we get the answer as 0. So this is how we do partial differentiation. Thank you.